Hey there, Year 12. So now in this exercise, we're going to be looking at how to apply recursion with matrices and what do they mean. So let's go back a bit, okay? So before I describe the entire process, let's go back a bit and let's have a look at this example here. This is one of the examples that we had done previously together where we looked at factory machines where they were operating and broken. So you remember in our previous examples, you had operating at the start of the day and breaking at the start of the day, or by the end of the day, will it still be operating or will it be broken? Okay, so this was the start of the day and this was the end of the day. We worked out in the first part was to represent it in a transition matrix, and we have 0.85, 0.15, 0.05, and 0.95, right? So this is our transition matrix. As you can see, they've got over here. From here, they ask us what they've made difference here is they say, if at the start you had 80 machines that are operating and 20 are broken, okay, they're trying to give you a scenario that there are 100 machines to start off with. So I'm going to write here 100 machines, 80 of which were operational and then 20 of which were broken. Okay, so operational and then broken. If we were to calculate, if the question was to say, well, how many of it by the end of the day were operational? Okay, so out of the 100, how many were operational and how many were broken by the end of the day? Because it started off as 80 and 20, right? That's how many operational. But then by the end of the day, how many are actually broken and how many are actually operational, right? After one day. So this is the transition. This is the probability of it being operational or broken. So how would you have done that? So to do this, what we would have done is, well, let's look at the operational side. When it was operational at the start and by the end of the day, it was 85% chance of the 80. Okay, so I'm going to write that down to help you understand. So for it to be operational, it had to be 85% of the 80. That tells me how many were operational by the end of the day. Okay, so at the start of the day, 80 of them were operational, but by the end of the day, how many were still operational? 85% of them, right? But then don't forget, by the end of the day, there's also still the chance that some of the broken ones, I'm going to use a different color, some of the broken machines actually became operational, and we have 5% of them. So if we were to calculate them, what we would have done is we would have said, oh, well, adding on an extra 5% of the 20 machines, because remember there were 20 that were broken, but 5% of them are going to work. So by the end of the day, if I wanted to know how many were actually operational, well, let's calculate 85% of 80. So I'm just going to do it here, 85% of 80. So 85% of means times 80. That tells me 68 cars. Okay, so when I work it out, 85 over 100 times 80, that worked out to be 68 cars of the 80 were operational by the end of the day. Okay, plus 5% of 20. So 5% of 20, 5 times 20, that means there's 1. Okay, so 5% of 20, 5 over 100 of 20 worked out to be 1. So in total, there are 69 cars that in total, not cars, machines. By the end of the day, out of the 100 machines, okay, I can say that 69 of them were operational and likely then broken is the remainder. So that means 31 of them were broken. Okay, and you can work out broken by following the same idea. You can go broken is equal to, in this case, if I use a different color over here, 15% were operational at the start of the day. So that means you can do 15% of the 80, okay, plus 95%, whoops, 95% of the 20, this will mean that at the end of the day, it will stay broken. So you can see that the calculation for this takes a while to do, doesn't it? It's 15 over 100 times 80, and then plus 95 over 100 times 20, and I don't know what this is. I'm going to have to calculate it. 15% of 80, so 15% of 80, and then 95% of 20 is 19. So 12 and 19, and you can see 12 plus 19 is 31, which is what I've calculated before. Okay, so this is what we had to do in order to find out how many were actually after one day. And then you can actually do it again, and that's you can do it again and say, well, now that I know at the end of one day, so remember I started off at 80 operational, 20 that were broken. So I'm going to do O and B here. That's day 1. Day 2, operational and broken, I now have 69 and 31. Okay, so the question is, if I continue this pattern, where I'm now going to times this by the transitional matrix again, do the same thing, or figure out the percentages. 85% is, if it was 69 here, I can do again 85% of that, and then 5% of this will work. Then you do that again, you get another third day, so day 1, day 2, day 3, you can continue on. That's what this exercise is about. But there has to be a shorter way of doing this, right? And there is. So to illustrate this point, I'm just going to probably make a bit more space. Actually, I'm going to make this smaller, just so I can move it across. So hopefully you're starting to see what I'm trying to do here. I'm trying to work this section out quicker. There had to be a quicker way to do this, okay? So how do we do that? And what you can see here is there was a pattern. See, it was 85% of 80 and then 15% of 80. That 85 and 15 actually came from this section, true? And then the 5% and the 95% came from this section. And so actually, what you're doing in your matrix form is actually when you write 0.85, 0.15, and you do 0.05 and then 0.95, a 2 by 2 matrix, if you multiply this by the very start value, so starting value, which we had 80 operational and then 20 broken, this is a 2 by 1, and you can multiply them because these two are the same. That means your ending result should be a 2 by 1. So you should expect 2 rows and 1 column. Okay? When you multiply this, remember multiplication matrices is doing the same thing. It's row 1 times column 1. You can see that it actually ends up being the same thing. It's 0.85 times 80 and 0.05 times 20, and you add them two together. That's what we did over here. 85% of 80 and then 5% of 20. And so actually when you type in your CAS, so if I go back to my CAS now, instead of doing it manually before, I could have gone straight to do transition matrix, which is 0.85, 0.05, 0.15, and 0.95 multiplied to the starting matrix, which is how much I had to begin with, 80 and 20, so 80 operational, 20 broken. You see, I get 69 and 31 straight off the bat. So this is day 1 of the matrix. Okay, so you can see here, I'm just going to copy paste it and get you to think a bit. Have a think about what I've been saying so far. I'm trying to explain to you how this transition matrix, how you're going to then apply it to recurrence. Now, if it's too much in terms of mathematical concept, you can essentially ignore what I've said here and previously. I'm just trying to let you know, understand the mathematics behind it. Okay, so very brief mathematics behind it. But in this first part, they're just trying to teach you how to use recurrence, because this is how you can do it for day 1. And all we did here was transitional matrix multiplied to what we call the initial state. Okay, so S0. So this now creates what we have here, recurrence relation. S0 is the initial value. It's the matrix that you start off with. And then to work out subsequent days, Sn plus 1, the transition matrix multiplied to the previous value. So this is what it's similar to recurrence in what you did with financial modeling. You see, what we used to do was something like, say, if I did 8,000, right? And then the recurrence model could be, so I could do, remember recurrence model, we did something like V0 is equal to, say, 8,000, and then Vn plus 1, I might say Vn minus 100, right? Then to repeat that recurrence, you would then say minus 100, and you just press enter, enter, enter. So it's just dropping down by 100 each time. Yeah, that's recurrence. So what if it's similar in this sense where we're going to multiply instead? What if we took Vn and we times that by a percentage? So say it increased by 5%, okay? Increased by 5%. If you remember from recurrence modeling, you did 1 plus 5 over 100. So that's increasing by 5%. Multiplied to Vn. So you can see here, if I model it, starting off with 8,000, answer is multiplied to 1 plus 5 over 100. So it means that you're increasing by 5% because 1 is itself, so 100% of itself, plus an extra 5% means you're increasing it by 5%. So there you go. You now get, if I keep pressing enter, it will always add on the 5%, okay? So, sorry, it's in the exact values. That's why it's in fractions there. But we're doing something similar now. We're going to be applying the recurrence formula in a similar sense. Instead of V0 and Vn plus 1, we are now applying S0, okay, which in our case was 80 and 20. And then our recurrence pattern was Sn plus 1 is equal to the transition matrix multiplied to Sn. So to answer this question, and to at least teach you from here, this is what you should be working with if you understood everything I said up to now. We can now work out not only for day 1, so this is, remember day 0, you had 80 operational, 20 broken. Day 1, it was then 69 and 31 after, going through the percentages of the chances of being operational or broken. You can work out for day 2 in a similar fashion. So day 2, this is how I would have done it. So on my CAS, remember, I'm going to now do the proper way. I'm going to use this, and I'm going to say I start off with 80, 20, right? And I'm going to store it as S0, okay? So S0. And then I'm going to say transition matrix. So I'm going to type in the transition matrix again. That was 0.85, 0.05, 0.15, and 0.95 from memory. Is that right? Yes. Okay, so I'm going to store this now as T as my transition matrix. And then from here, I'm going to start my recurrence. So the recurrence is T times S0. So this tells me day 1. So day 1 was 69.31. Now, unfortunately, it's not similar to recurrence modeling where you can just keep pressing enter, because in matrices, the order of multiplication matters. You can't do the other way around. You can't do S0 times T, because S0 is a 2 by 1 matrix and the transition matrix is a 2 by 2, and you can see these don't match. So that's why we always have to continually type it. So here I'm going to type T times. Now to get the next one, this is the new day. So at the end of day 1, I now have 69 broken and 69 operational and 31 broken. So on day 2, this is how much I'm starting with. I'm starting with 69 operational and then 31 broken. But if I follow the same percentages they told us at the start, where if it's operational at the start of the day, then by the end of day, 85% of them will be operational. Then following that, I can now work out day 2 by simply multiplying transition matrix 2, and I go up and highlight the day 1 matrix, pop it down, press enter. This now tells me 60.2 of them will be operational, and then 39.8 of them will be broken. And then I can continue that pattern. I can do T times and go up and highlight. This is now day 3. Okay, so day 3 is now, you can see here, 53.16 and 46.84. So 53.16 and 46.84. So what I'm doing here is, you can see I started off with 80 operational, 20 broken, but by the percentages, and if we calculate them, we can calculate day 1, day 2, day 3, and day 4 recursively. Okay, so this is the first part that I'm teaching you how to do it recursively. Sorry, give me a second. So this tells you how to do it recursively, but you can see how the technique works, and it's simply S0 is how much you start off with each day, and then take the previous one, multiply to the transition matrix. That's how you move forward. Okay, so in answering this question here, they want to determine the number of operational and broken machines after 1 day. Well, we got 1 day. The answer was, this is day 1. But then day 3, let's go back over here. Day 3, you can see that I've got over here, day 3. Day 3 told me that operational and broken, operational is 53.16. So you can say it's about 54. You always round it up, because machines, you can't have 53.16. It's more than 53. So it rounds to approximately 54 will be operational. And then 46.84 technically is 47. But the problem is that if you say 47, 54 plus 47 does not equal to 100 cars. You're meant to have 100 cars. But you can say it's approximately 54 and 47. Technically, if I were to answer the question to make it rounding to the nearest car, then technically it's 53 and 47 together. That adds up to 100 cars. Okay? So that's the concept there. That's how you would answer the first part of this video. Okay, so I know it was quite a bit there to take in. In the next video, I'm going to show you how to calculate, not recursively, but to find the nth rule, so that you can find 99th day or 100th day, instead of doing what we just did before in a CAS, where you're essentially doing T times and you use the previous day, enter, T times the previous day, enter. It takes a long time to do. Okay, if I want to find the 99th day, there is a way to do it, and that's going to be in my next part of the video. Okay.